Today I'm going to be introducing WhizzML to you guys. So like Amir mentioned, this is the first part of 4. So in this presentation, we're just going to go over some basics, like what is WhizzML, why did we make it, and then we'll look at a certain workflow through a bunch of different ways where we can do this workflow, and we're going to look at it without WhizzML, and then we're going to look at how we can do it now that we do have WhizzML. The next thing we're going to talk about is how we implemented WhizzML on the BigML platform. So WhizzML are new types of BigML resources, and we'll go over that. I'm also going to do a basic web UI walkthrough so that when you guys are exploring the BigML website, you won't be totally lost as to how you can test out WhizzML. And then we'll be talking about the gallery too. And the gallery already existed for models and data sets, but we think it's going to bring an extra big punch to WhizzML, so we're going to also go over that again. We're going to end by going over the WhizzML language itself, and then talk about some very basic use cases. So, to get started, what is WhizzML, and why did we implement it? WhizzML is a programming language for automating machine learning workflows. It is a domain-specific language on the BigML platform. It's also a framework for implementing high-level machine learning algorithms. So now we can write these algorithms in ways that are much easier and much simpler than before. And finally, it's an infrastructure for sharing machine learning workflows and algorithms. So with the gallery, now we don't have to reinvent the wheel every time we implement one of the traditional algorithms or a workflow. So diving a little bit deeper, why is WhizzML important? Well, first of all, WhizzML lets us use a machine learning workflow or algorithm from any programming language. So before, if we had a Python app, we can code the different steps of a BigML workflow in Python, and we're going to see an example of this later. But then what happens if you have another language that you want to use it from? You'd have to rewrite it. So WhizzML solves that problem. WhizzML also lets us perform all the intermediate steps for a workflow on the server. And what that means is it eliminates client-server latency, the client and the server exchanging messages back and forth, waiting for responses. And it also reduces the dependency on a connection between the two. So on the bottom, the code there is just a small example of what WhizzML looks like. And we're going to have a chance to dive a bit deeper into that and take a closer look later. So the first thing we're going to do is look at a workflow for creating a batch Centroid, a number of different ways, and then finally looking at how we can do it with WhizzML and how it makes it much easier. So the first thing we're going to do is use the web UI to do this batch Centroid workflow. And what this workflow, the objective of it is to label each row in a data set with its associated Centroid. So to do this, we need to first create a data set from a source. Then we need to create a cluster from that data set. We need to create a batch Centroid prediction from the cluster and the original data set. And then we need to save that batch Centroid prediction as a new data set. So let's jump over to the web UI and see how we can do that. So you see here is our sources panel. You guys are probably familiar with this. And if we go down to our diabetes source, we're going to create a data set from this. So if we come up here and just make a one-click data set, there we go. And the next step, if you remember, is to create a cluster from this data set. So we can come back up here and say, make me a one-click cluster. And what this is doing is it's creating 8 different centroids that each of the data points will be centered around based on a k-means algorithm. So now we have our cluster, and what we need to do is create a batch Centroid prediction from this cluster and the original data set. And we have a little shortcode where we can do this up here. And on the left we have our cluster, and on the right we need to tell it what data set we want to use. And this again is the same one we started out with. So this is the diabetes data set. Now we come down here and we say predict my batch centroid. And we can go ahead and take a look at the output data set. And what we wanted was a new field that predicts which centroid it belongs to. So if we go to the next page, we see here, we can look and see which of the clusters each row is assigned to. So that's great. So we finished that workflow through the web UI. So jumping back, this is just one of the ways where we can do this workflow. Another way is if we code it in Python. So on the right, you see an example of Python code. So what we do is we import BigML, we create an API, we tell it which source we want to use, then we create a data set from the source. We need to make sure that the data set was created correctly. Then we create a cluster from that data set. Make sure the cluster was created correctly. And then finally, we create a batch centroid prediction. We want to save it as a data set, and we pass it the original data set. And then we also make sure that that new data set was created correctly. So we can imagine that if we're doing this workflow, maybe 20 times, we probably don't want to use the web UI, and we can code it in Python. And this is much better. Now we can just run the script and it'll do all these different steps for us. Right? But still here, this code, sends 6 HTTP requests. And then we also have the question that, again, like I said, what if we have a Node app and we want to do the same workflow? Well, we could create an API for this Python script and call it, but that might get a little bit tedious. And then the problem with the HTTP requests is that, again, if we have a more complex workflow, something like cross-validation, then it's not 6 HTTP requests, but it's, it could be upwards of 600. So this client-server relationship dependency could become problematic. So how does WhizzML help us solve these problems? Right now, I'm going to demo through the web UI something that makes it much easier. So let's jump back over to the web UI. And we're going to go back to our list of sources. We go down to our diabetes source. And in the top right, we've got a new menu up here. And what this is it allows you to customize the web UI to add your own workflows to it. So right now we have a batch centroid WhizzML script. And if I click on this option here, it brings us to a new page, and we see it's doing something. What is it doing? It's doing all these different steps that we talked about before. It's taking the source, it's creating a data set, it's creating a cluster from that data set, and it's creating a batch prediction from the cluster in the data set and outputting that to a new data set. We can see all those different resources created down here, and we see that it gave us an output data set. So if we click on this, and we go to the next page, we see that it indeed did give us the exact same result from the web UI workflow. So now instead of the dozen or so clicks through the web UI to do this workflow, it's 1 or 2 clicks with WhizzML. So it's much easier. Another way we can use WhizzML is through an API. And this is the same BigML API. We're going to talk a little bit later about how WhizzML Resources are first-class BigML resources, just like sources, like data sets, and like models. So we can execute a workflow from the Python bindings or from any of the other program languages that we have. So what are the advantages here? Well, for one, we only have one HTTP request. All we have to do is choose which workflow we want to use. Then we also give it any of the necessary inputs, and then we tell the API to create my execution, which is just the same thing as run my script. And all of the intermediate steps are executed server-side. So again, if we did something really complicated like cross-validation, we don't have all these HTTP requests going back and forth between the client and the server. All of this is handled on BigML's end. Great, so we've seen WhizzML can change our BigML lives. This is awesome. How do we implement WhizzML on the BigML platform? So we're going to talk now about the different WhizzML resources. So we implement WhizzML with 3 different resources. The first is called a script, and this is sort of like our basic resource. This is where we define a workflow or an algorithm that we want to run. This is where we tell it which are the necessary inputs and what are the outputs are we going to get from this script. An example of a script would be, like we just saw, the batch Centroid. So we create a data set, create a cluster, create a batch Centroid prediction, and output a data set. So that's an example of a script. We also have a resource type called a library. And if you're a programmer, you can probably guess what this is. It holds imports for scripts. So we can define functions or constants that we can then import into our script, as opposed to rewriting all the code that defines these in the workflow or algorithm. An example of a library might be dataset transformations. So a bunch of different functions that take in a dataset and output a new dataset based on some criteria we define. It could be maybe we're removing a field, or we're adding a ratio of 2 fields, or we're filtering out fields that aren't populated enough. So that's what a library is. And lastly, we have an execution. And an execution holds or runs a script. So if we create an execution, we run a workflow. And in the execution resource, we can see, like we saw briefly, and we'll go back over this, we can see all the different resources created during the execution, as well as the defined output. And we're going to take a look at all of these just a little bit later. Lastly, I also want to talk about the different ways we can create WhizzML scripts and libraries. So executions we create by running a script, but actually importing source code onto the BigML platform can be done a few different ways. We can import code through a GitHub gist. We can write the code ourselves in an in-browser editor. We can copy existing scripts from the gallery, which we'll talk about later. Or we can take an existing script or library and create another one based off that if we want to add something to it, or we want to remove a feature, or maybe tailor it towards a different kind of BigML resource. So now we'll jump back to the web UI, and I'll give you a brief tour of WhizzML here. So if we look at the top right hand of our dashboard, this new menu, and if we hover over it, we can see scripts, libraries, and executions. And clicking on either one of these will bring us to a listing view that we're probably pretty familiar with. So here's a list of all of our script resources. We can see when it was created, the size of the file. And if we click on one, we can see a bunch of different things. This is the main view of our script resource. So we can look at the source code. We can see the description, and this also gives us the opportunity to run the script from this view or create an execution. So if we wanted to, we could come here and go to our diabetes source and actually run this. And we're not going to do that right now, but we could if we wanted to. So that pretty much wraps up viewing scripts. So let's take a look at libraries. So this is pretty similar. It's the same thing. We see all our libraries here. If we click on one, we can see the source code. And then down below, we can also see all the different constants or functions that this library exports. So when we create a script, we can actually tell it to import this library, and then we have access to all these defined functions here. Lastly, we're going to go take a look at executions. So we can see we've run this twice, once just now and once a little while ago. And if we click on it, we can see how long it took to create. We can see the total number of resources created. We can again look at the source code of the script that we used. And we can see our output data set and all the different resources that were created during this. So that's cool. So those are all the different resources. Let's actually jump back to scripts for a second and see one of the ways where we can import, or rather create a script. So from here, if we look in the top right-hand corner, we see this new option where we can import a script from GitHub, or we can write a script using the editor. And I'm not going to bore you guys with writing a script in the editor. We'll save that for another day. And instead, I'm going to import a script from GitHub. So we'll click on this. And all you have to do is give it the URL of a GitHub gist. And what's contained in the gist is 2 files, and all of this is explained very thoroughly in the WhizzML documentation. All it contains is 2 files, one for the source code of the workflow, and another containing metadata. And this will make a bit more sense once I actually import this. So you see the source code is defined here, and the second file, this JSON metadata file, actually specifies how many inputs there are, outputs, what type the inputs and outputs are, and we can also give it descriptions for these fields too. So if this looks all good, it says our source code is valid. We can click create. And here we have our created script, and again, this is one of the ways where we can create an execution or run the script right here from this menu. So jumping back, next we're going to talk about the gallery. So if you're familiar with the BigML platform, you probably already know that we have a public gallery for models and data sets where you can look at other people's models and data sets who have chosen to make them publicly available, and we can copy these resources and use them. So we're implementing the same thing with WhizzML, and we hope that it's going to be a big time saver for you guys. Because once we have these workflows or algorithms coded in WhizzML, all you have to do is clone it down and you can use it just like that. Because WhizzML is its own domain-specific language on the BigML platform, we don't have to worry about someone implementing something in Python and then translating that or vice versa. All this is in WhizzML. It's ready for you guys to use. So let's jump back and I'll show you how we can clone something down from the gallery. So up here on the top, we have a link to the gallery. We can click on it. And here we see a bunch of different script resources that the BigML team has put together for you. So we can do best first feature selection, we can find neighbors for a cluster in a given data point, we can do cross-validation, we can remove anomalies from a data set, all these different things. So let's look at finding neighbors. So let's click on this resource. Now, if the resource is listed for free, which this one is, we can look at the source code, come here, we can look at the different inputs required to run the script. We can also look at the outputs. And if we decide that this is worth the price, in this case it's free, so yes, of course it is. Click there, and we confirm. And right now this is creating a copy of this gallery resource on our own account. So now we can access this from the same script menu, and we can go in here and we can run this script or create an execution using this gallery script whenever we want. So that's pretty cool. So we hope that the gallery does 2 things. One, gives you inspiration to look at some of these more advanced machine learning workflows and algorithms, especially if you don't have the deep technical expertise that some other people have. And 2, to save time, maybe someone has implemented a workflow, maybe removing anomalies from a data set, right, that you might be using a lot in. You don't have to reinvent the wheel. You can go to the gallery and clone a copy of that resource down for yourself. So let's go back. And what's next? We've got the WhizzML language. So we're just going to talk really briefly in the next session. Another member of our team is going to go over more in depth about the WhizzML language, but I just want to introduce it here. So if this is your first time, you can start playing around with it. The first thing, it is a Lisp-like language, so you'll see parentheses there, a prefix notation. On the left is an example of simple addition, and then right next to that, defining a new function. And then I also wanted to highlight how we interact with BigML resources in WhizzML. So if we want to create a data set from a source, we see this first function, create and weight data set, that's included in the standard library. We tell it it's a source, this is my unique identifier, and it'll return a unique identifier for a data set. And the next function below it, called fetch, what this does is we give it the unique identifier for a resource, and it returns a map or a JSON-like object of all the different attributes of that object. If you go to BigML.com on the labs section, the labs section, we have a new labs app, and it's a WhizzML REPL. So you can actually go on there and interactively use WhizzML and try it out for yourself. So a few other things about the WhizzML language. We have all the standard data types, so lists, maps, booleans, strings, procedures, which are functions, and numbers. We have conditionals, and we also have higher order functions like map, reduce, and other things like that. There is a full WhizzML WhizzML language reference manual that we do have published online. So if you have any questions, you can always refer to that. And I think playing around in the REPL is another great way to get used to the language. So finally, to wrap it up, let's just talk about some really basic use cases. So, you know, we just want to present this here to sort of get everyone thinking about how they can use WhizzML to make their lives easier. You know, what are some basic workflows that I maybe do a lot that I'd really like to automate? And so one we thought of was removing anomalies from a data set. So we have a data set, we need to create an anomaly predictor, we need to run that through the anomaly predictor, create a new data set without those anomalies, and then maybe we want to create a predictive model and then some batch predictions based off that, right? And by itself this doesn't take too long, but what if we have to do this, you know, every week for a number of different data sets? Then it gets kind of tedious, and WhizzML could really be a big help. So we want you guys to start thinking about what workflows would you automate. The next thing is thinking about higher level machine learning algorithms. So if some of you out there have the technical expertise to start, you know, thinking or sort of have the desire to start writing these in WhizzML, you know, we do have a few examples up, like boosting and cross-validation. And since creating data sets, creating predictive models, and evaluations are all sort of like primary functions of WhizzML, like a lot of high-level machine learning algorithms, we think this will be a really cool tool for you guys to start working with. So with that pretty much wraps up what I've got. Just to briefly go over again what we've learned about WhizzML. It is a domain-specific programming language designed to increase our BigML productivity, especially with the gallery, where we can not reinvent the wheel and look at workflows and algorithms that others have already implemented and copy them down and use them as is or tweak them as we see fit. And we also hope that it'll simplify your processes and your BigML workflows, where we reduce the client-server dependencies and the other headaches that come with that. The next sessions will be going over more in depth on the WhizzML language and basic workflows. We'll also be looking at some more intermediate workflows, and then finally advanced workflows and real-life examples of how someone would use WhizzML and with sort of a complex task before them. Hopefully you guys are excited about using WhizzML. Thank you.